Okay, so hi everyone. So today in this video, I will be discussing solutions to the first 6 problems of AtCoder Beginner Contest 306. So let us start the discussion one by one. Okay, so this was the first problem, echo. So this is a very simple problem. You are given a string s of length n, and what you have to do is to print a string of length 2n, which is obtained by concatenating the first character 2 times, then the second character 2 times, like this in this order. So for example, if your string is beginner, you will just print b 2 times, then e 2 times, then g 2 times, like this. So there is nothing much big in this. So I will be quickly showing you my submission for the same. If you feel any doubt, you can ask. I don't think you will be getting any doubt because this is just a very basic C++ program. So So in this, as you can see, I am just taking the size of the string n, then taking the string, and then for every character which is there in string s, I am just printing the character 2 times in the order from left to right. And at the end, I just print the endl. Okay. So this was about problem A. Okay. Now I would be moving to problem B. So this problem is called as base 2. Okay, so in this problem you are given a sequence A where A is equal to A0, A1, A63 of length 64, and it consists of only zeros and ones. And you have to print the value of this expression, which is A0 multiplied by 2 to the power 0 plus A1 into 2 to the power 1, so on and so up to A63 into 2 to the power 63. Okay, so if you see it, you will find that this value is nothing but the decimal equivalent of this binary representation of A. Okay, so the length of A is constant, that is, it consists of 64 values, and you have to compute this. Okay, so an immediate idea which might strike you is to just evaluate this as it's given in the problem. So let me show you. Sorry. Okay, so you are able to see my screen, right? Okay, so I was
Yes.
discussing, yeah. So let's say your 1 0 0 1 0 1 like this, you are given like this. So all you have to do is to, like, simply, whenever there is a 1, you just add the 2 to the power, whatever is the weight of this index, like 2 to the power 0 plus this is 0 1 2 3 plus 2 to the power 3, like this. Okay, so if you try to compute it naively or like in a very simple manner, so you might think it will work, but if you try to find out what can be the maximum value of this in this decimal value, so what happens if there are all the ones? So all the 64 integers are basically ones only. Then what will be the value of this expression? That will be nothing but 2 to the power 0 plus 2 to the power 1, so on and so up to plus 2 to the power of 63. Okay. Now if you try to calculate its value, this will come out to be 2 to the power 64 minus 1. Okay. So definitely you cannot store this big value into a data type integer, because the maximum value an integer can hold is nothing but 2 to the power 31 minus 1. Okay, so then you might try to think, okay, if I can't store it in integer, maybe I can use long int. Okay, but actually long int, if you try to use it, even its maximum value it can store is only 2 to the power 63 minus 1. But here what we are having, here we are having 2 to the power 64 minus 1. So what it means is that if you try to compute the value of this and store it in a long int data type, even that would overflow. Okay, so what we will do now is that there are like multiple approaches to handle the overflow. Okay, so the first approach is that you can use an unsigned long int. Okay, you can use unsigned long int. So why unsigned long int? Because unsigned long int, the range of this is basically the maximum value it can store is double of this value. Okay, so it's 2 times around 2 to the power 63 minus 1. Okay, so that's why if you are using an unsigned long int, so it won't be overflowing. Okay, so this is one approach you can do, or otherwise what you can do, you can use something like double or long double. Okay, long double. So the range of this is something like 2 to the power. I am not sure, but it's definitely 2 to the power, not 64, but something like 108 or something even bigger than that. So you can also store the value of that expression in a long double of data type of long double. Okay. Or like you can also do one thing, you can store everything in a string. So what I did was I used strings like let's say you have to compute these things, like you have to compute these. So what I do, I just made a function which can add two strings s and t, and which can multiply a string by 2. Let's say I made these two functions, and then instead of storing everything in a form of integer, I stored everything in the form of strings. Okay, so if I will show you, you will realize what I am actually talking about. Okay, upper bound of unsigned. So actually I am not sure, so we can check it. So maximum, or you can simply say range
Sir, I
of,
submitted with unsigned, but it worked.
yeah. So let's check only what is the maximum range of this.
So your voice is lagging
Yeah,
actually.
is it lagging even now?
No,
Hello.
sir, it's better. It's better now.
Okay. So yeah, you can see that the value, maximum value of unsigned long is something like this. So if you compare these, you can see that this is like around double of it, I guess. Yeah, double of this plus 1. Yeah, you see.
Sir, I have a doubt. May I ask?
Yeah, yeah, yeah.
Sir, I used double, but when I was printing the value, it was printing its scientific value, like
Yeah,
1e something. So how I can remove that e and print the
yes.
original one?
Yeah, so yeah, if you will be using double or long double, what it will do is that instead of printing 2, it might print something like this, 2.000. Okay, so for like cutting out these decimal places, you can use something called as fixed and set precision. So you can
Sir,
print,
it was printing something
uh,
1e and then power something.
so you try to print it in this form: C out, fix it, set precision of 0. Okay, you try printing it in this way, and whatever is the like variable where you are holding the expression value, so in that case it won't be giving you like these decimal places.
Okay, sir, got it.
Okay, so that was the second approach of using doubles. The first was using unsigned long, the second is using double, the third is what I have used, so I can show you. So I basically used strings for the same. Okay, so like here the length of the array was 64. That's why using unsigned long worked. But let's suppose what happens if the array was given of length 100 or maybe 1000 or 10,000. So there you might not be even able to use unsigned long or maybe double. So the only thing which would be left in that case would be to use strings, right? So okay. So let's see. So first of all, I initialize my answer as 0. Now current will store whatever, what is 2 to the power i's value. Okay, so for example, for I is equal to 0, current will store 2 to the power 0. For I is equal to 1, it will store 2 to the power 1, that is 2, right? So I just take x, right? And if x bit is on, so I will simply be adding the value of 2 to the power I, that is stored in current. So since my answer and current, both of them are strings, so I will be adding them in the form of strings. And then I am simply updating my current by multiplying it by 2. So current is equal to like multiply it by 2. Now these are my like two functions. So the first one is adding of two strings s and t, right? And then there is a function called multiply s, so that will multiply s by 2. So multiplying s by 2 is nothing but adding s to itself, so s plus s. So that's why I'm returning add of s plus s, like s comma s. Now the logic is quite like very simple. Like I check the sizes of S and T. If S size is smaller, I swapped it. So I am maintaining the condition that S size is always greater than T. Then I found out the size of S and T, and then I kind of reversed it and made the sizes of S and T equal by appending zeros at the end of T. And then I followed that similar elementary school logic where you add the decimal digits one by one and forward the carry to the left. Okay. And at the end, I return my answer. So I think if you try to go through it, you will get the logic, like how we can add two strings. Okay. Or if you need any doubt, if you are having any doubt, you can ask now. Like voice lagging. Is my voice lagging?
No, sir. It
Okay.
is fine.
Yeah. So this is the logic for adding the digits one by one. So like let's see only this. So let's say if there are two numbers, 235 and 75, and we need to add it. So how do we add it? We start adding the digits from here. So 5 plus 5 goes 10. So 10, instead of writing 10, we write the this digit, that is the digit at the ones place. So how we can get this digit? By taking its modulo with 10, right? So if you take its modulo with 10, you will be getting 0. And what is the carry? The carry that goes to the next digit is nothing but 10 by 10, that is 1. Okay, so now carry becomes 1. You add these things together, it becomes 3 plus 1 4, 4 plus 7 is 11. Again, what will be the digit at this place? This will be 10 modulo 10, that is 1. And what will be the next carry? Carry will be nothing but 11 by 10, that is 1. So you again do like this, and similarly you can form it like this. Okay, so this is the very same logic I am doing, is that you find the values at the two positions, and then the new value will be val1 plus val2 plus carry. So the value at this position will be modulo 10, and the carry will be like by 10. Okay, and if you are still having
Sir,
carries, yeah,
can you repeat why you have appended zeros at the end
yeah,
in
I
a
can
point?
show you. Yeah, so let's say we need to add these two numbers, that is 235 and 75. Okay, so what we do is that we first of all reverse these two. So let's say we reverse this, like it becomes 532, and this becomes 75. Now I try to append zeros in order to make the length of this string equal to this string. Okay, and after that I start adding these one by one from left to right, because in actually we go from right to left, but since we have reversed the strings, we will be going from left to right.
Yes, sir, got it. Thank you.
Okay, and zeros is added so that you can add these two, right?
Sir, got it.
Okay, so that's why we reversed it. So you see here, we have reversed these strings, and then we have added appropriate number of zeros, and then we have added them in an elementary school logic. And if there is still some carry left, we just add its value by putting, like finding out the 10th ones digit and propagating the carry forward. And at the end we reverse the answer, because whatever we will be getting will be the reversed value. For example, if you try to add these numbers, you will be getting 0 1 3. So you need to reverse it again to get the actual value. Okay, so this was through the use of strings. Okay, do anybody having any doubts? Okay, so if there are no doubts, then we can move to the next problem, which was problem C. Okay. Okay, so in problem C, it's given that you are given a sequence A that is consisting of 3n elements, and each of the elements is 1 to n, and each element 1 to n occurs exactly 3 times. So we are now defining f of I is the index of the middle occurrence of I in A. Okay, so every element I is occurring 3 times, and f of I is the occurrence of the middle element, or the second occurrence of I in A. We need to sort 1 to n in ascending order of f of I. Okay, so whichever I has the minimum fi will be occurring first, then next, like this in the ascending order. Okay, so for example, in this case, if you see, what is the middle occurrence of 1? 1 is occurring, the middle occurrence of 1 is at this place, which is place 2. right? Similarly, the mid, that's why you see 1 is occurring very first, because anybody other's middle occurrence is like greater than 2. For example, 3 is occurring at this 5th place, and 2 is middle occurring at this place, 6th. So that's why the answer is like 1 3 2. Okay, so you calculated these FIs and arrange them in this order, 1 3 and 2. Okay, so there are various ways of solving this, right? So what I did is that I first of all found the middle occurrence of each of them, and I stored them in an array. Hello. Okay, so I stored the middle occurrence of each in mi, and there is fi is actually storing the first occurrence of each integer. Okay, after that I simply stored all the elements in a vector v. So vector v will be consisting of 1 to n, and then I just simply wrote sort v dot begin, v dot end, and just I passed a comparator. Okay, so that comparator will basically return m of like x is lesser than m of y. Okay. Okay, so if the middle occurrence of x is smaller than y, then x will be placed before y. Okay. You can also do it in another way also. You can store everything in a form of pair. So vector v might contain something like what is the middle occurrence of I comma I, and then you can simply sort this by the first position, and then you can print the second values of all the elements in the vector. Okay, so this is what you can do for problem C. So let me show my code for this. Okay, so in this problem, as you can see, I am first of all taking the size of the array. Sorry, size. Yeah, size of the array. So the size is actually 3n, but it consists of 1 to n elements. Then I am storing, like I am declaring two arrays, f of f and m. So f will be storing the first occurrence, m will be storing the second occurrence. So I take the elements one by one. If this element has never occurred before, so this is the first occurrence, so that's why I store it in f of x. Otherwise, if it has already occurred for first time, then if it is not occurring for the second time, that is m of x is -1, then I set m of x as I. Okay, so in this way I calculate the middle occurrence of each I. After that, I store all the elements from 1 to n in a vector, and then I just apply this sort function, that is sort v dot begin to v dot end, and this is like a lambda comparator or lambda function. So you can also declare another comparator and pass that comparator here, but I generally use this comparator. I pass comparator like this, that is you declare this and then enclose it with the square brackets, and then pass two integers, since two like long int, since vector is the elements of the vector v are long, so I passed long x and long y. So and then I just say how I want to sort it. So I want to sort it in this order, that is if m of x is smaller than m of y, then x would be placed before y, and at the end I just print the all the elements of vector v. Okay, so this was for C. Does anybody have any doubt? Hello. Okay. Okay, so if there is no doubt, then we can move to the next problem, which was problem D. Okay, so in this problem, Takahashi has decided to enjoy a wired full course meal consisting of n courses in the restaurant. And if xi is equal to 0, then it's called an antidotal course. And if xi is equal to 1, it means a poisonous course. So you can also say it like this, that if xi is equal to 0, it means it's a healthy food. And if xi is equal to 1, it's a poisonous food. And each food has a tastiness associated with it, that is denoted by yi. Now what we have to do, so there is Takahashi, initially he will be healthy, and whenever he is healthy and if he eats healthy food, then he remains healthy. right? And if he is healthy and he eats a poisonous food, he gets an upset stomach. Okay, so he becomes unhealthy, you can say. And if he has an upset stomach, that is, if he's not healthy, and if he eats a healthy food, he again becomes healthy. Otherwise, if he is unhealthy and again he eats a poisonous food, it dies. Okay, so what we have to do, we have to like basically process these foods from 1 to n, and we can either take a food or not take it, or you can say we can skip it. So we have to find the maximum possible sum of tastiness of the courses that we can eat, and we don't have to die. Okay, so that condition should be hold, and we have to find what is the maximum possible tastiness that we can achieve. Okay, so let's see what we can do for this. Okay, so initially we will be having some xi's like this 1001. So let's say these are my xi values, and there will be some yi's associated with it, like y1, y2, y3, like this. Okay, so for each one there are two possibilities, like either we take it or we don't take it, right? So if we take it, we need to add yi to our score, or like to our tastiness. If we don't take it, we don't have to add anything. Okay, so we have to maximize the total tastiness. So if you observe this problem, you will find that it's very much similar to knapsack. Okay, it's very much similar to knapsack. Why? Because in knapsack also we have always two possibilities, that is either we take something or we don't take something. Okay, so that's why it gives us an intuition to use dp, right? So what we can do, we can define our dp state like this, that we will say dp of I comma 0 and dp of I comma 1. Okay, so 0 will denote that after eating the foods up to I am finally healthy. Okay, and dp of I1 will denote what is the maximum tastiness that I can achieve by eating foods up to I such that finally I am unhealthy. Okay, so dp of I0 is maximum tastiness, finally healthy, and dp of I1, what is the maximum tastiness up to I such that finally I am unhealthy. Okay, so what will be the transitions? So the transitions will be like this. For dp of I0, you consider the ith position. So either you will skip it. So if you skip it, your maximum tastiness will be dp of I minus 1 0. Okay, or you can take it. Okay, so if you take this food, when you can take this food, you can take this food only if s of I, or like x of I is not equal to 1, right? Because if xi is equal to 1, then after eating this food you will be poisonous, or like you will be unhealthy, right? So if si is equal to 1, there you can't ever take this yi. Otherwise, if this is 0, then you can add yi plus previously. Either you can be healthy or you can be poisonous, it does not matter. Because by eating foods up to I minus 1, if you are healthy and again taking a healthy food, you are finally healthy. And even if you are unhealthy, you are again eating a healthy food, you will again become healthy. So this will be dp of I0 will be nothing but maximum of dp of I minus 1 0 comma yi plus dp of I minus 1 0, or yi plus dp of I minus 1 1. Okay, so these are the transitions for calculating dp of I0, right? Now let us see how we can compute dp of I1. Okay, so let's say we consider positions up to I. Again, the same thing can be said, that if you don't take the
Excuse
ith
me, sir.
item. Yeah,
Sir, I didn't get the last part. Can you please repeat that again?
yeah, sure. So so here we are calculating dp of I0. So the first thing I said is that if you don't take it, you will be getting this much, right? dp of I minus 1 0. Otherwise, you can take this. Okay, but when you can take this, you can take this only if si is not equal, sorry, xi is not equal to 1. Because if xi is equal to 1, it does not matter whether earlier you were healthy or unhealthy. After eating this, you will be either unhealthy or you will die. But you have to be healthy by up to this point, right? So that's why if xi is equal to 1, you don't take these two values. Okay, otherwise you will be taking this value. You will be like taking this food. So if you take this food, you will be getting yi, right? Now earlier what can be your state? Earlier what can be your state? Earlier either you can be healthy or you can be unhealthy. So if you are healthy and again eating a healthy food, you will be finally healthy only. So that's why yi plus dp of I minus 1 0 is what it represents. Similarly, you can also be unhealthy till I minus 1. So if earlier you were unhealthy and you are eating a healthy food, you will be again finally healthy only. So that's why I am taking maximum of these three values. Is this clear?
Yes, sir.
Okay. So this was
So
for,
can I
yeah,
share my approach?
yeah.
So it's basically like we cannot take, we should not have consecutive two zeros.
Okay.
So so what I have got it, I tried to implement that. Let us take a stack of pairs, and I will store both the values like y of I, and at that point of time, what is 1 or 0. So if the stack, if the top element of the stack pair, like pair first containing my pair dot first contains all the uh, in all the like contains 0 or 1. So I can say that if stack dot top pair first is equals to 0, and the current element which I am iterating is also 0, then I will skip it and skip to next, and will continue to skip till I get another one. And at last I will sum all the values of pair dot second by popping out the stack.
Okay. But like you have to maintain also that whether earlier you have taken some poisonous food or not, because if earlier you have taken some poisonous food, you cannot take again another poisonous food, right? So it's
Okay,
it's
okay, so
it's important that you maintain the state, like whether earlier you have used some healthy or unhealthy food. And also the yi values are not always positive. They might go negative, so sometimes it might be possible to skip the healthy foods as well if they are having negative yi. Okay.
okay, so got it.
So that's why we are doing with
Sunil,
this.
sir.
Yeah.
Sir, I had another approach in my mind that uh, there are 2, 3 cases which I observed, that if there is unhealthy food and
Okay.
there are continuous unhealthy foods, we should take only the maximum unhealthy food if they are consecutive, right? So what I'm doing, I'm taking a priority queue, and if there are consecutive unhealthy foods, I will keep all these positive values of unhealthy foods in the priority queue. And when I get a healthy food, I will check if that healthy food plus the unhealthy food, the priority queue top, gives me a positive value, then I should take both, right? And if we have nothing in priority queue, that means I'm still healthy, and the healthy food is giving me positive answer, I'm taking that.
Okay, but like
But
it's sometimes it might be possible that you don't have to actually eat a healthy food, because as I said, might be healthy food is having some negative value. So let's
no,
say, yeah,
I'm keeping that condition. What I'm doing is, when I'm on the healthy food, I see 2 things. First,
yeah.
I take out my top value from the priority queue, that is the last unhealthy food, which was, I mean, highest possible, maximum possible, and then I'm adding it with my current healthy food. If it is coming positive, that means I should have both of them, right?
Okay.
And if it is coming negative, I will just skip both of them. That's what
Hmm.
I'm doing. And it actually passed on 15 to 16 test cases, but it is giving wrong answer on rest. So
Okay.
I'm
Yeah,
not able
like
to
yeah, I
understand
think
why.
it might be missing some edge cases. So maybe we can like discuss it like after like discussing this approach. I think uh, like there might be some greedy cases where you would be failing, right?
Okay.
So I have to like think upon this, like, so what actually the test cases can be where you
So
would be
after
failing.
PCD, I will create a query.
Yeah, sure, sure. Okay. So you learned like how to calculate dp of I0. Now I would be discussing how you can like calculate dp of I1. So like dp of I0, you can again say that dp of I1 can be what, like either you take or you don't take. So if you don't take the ith element, you will be left with dp of I minus 1 1, right? Or what you can do is that you can take the ith element, so if you take the ith element, what can be the case? So there can be two cases, either x of I is 0 or x of I is 1. Okay. But if x of I is 0, then actually after taking this food you will always be healthy. Okay. Either you were healthy or unhealthy earlier, after taking this food you will be definitely healthy. But you want that after all you should be unhealthy, right? So it means that if as x of I is 0, then you don't have to actually take this, you can't take this. Okay, otherwise if x of I is equal to 1, then what should be the previous state? Should I be healthy or unhealthy? Definitely I should be healthy, because if I am earlier unhealthy and again I am taking this unhealthy food, I will be finally dying out, right? So this case is not possible. So here that there is only one transition. If you are taking this, that is you should must be healthier earlier. So in that case you will be reaching with dp of I minus 1 0. So you take the maximum of these two. Okay, so this is the transition for dp of I1. Okay, at the end what should be our answer? We have to finally consider all the foods up to the nth position. So your final answer will be either dp of n0 or dp of n1. Finally you could be either healthy or unhealthy, so you take the maximum out of these. And also 0 also you consider, because if you don't take anything you will be like having a zero tastiness value, so you take the maximum of these two. Now there is there is one base case. The base case will be nothing but dp of 0 0 is equal to 0, and every other dp of ij you initialize with some very low value like minus infinity. Okay, so I am considering one based indexing, that's why 0 means that an empty empty array, or like no elements, no foods, and you are healthy, so that's why dp of 0 0 is 0. Okay, so let me show me my code for the same and you will understand it better. Okay, so here what I'm doing is that simply taking xi's and yi's. So these are xi's, yi's. Then I am declaring this dp array. So I am initializing all the dp values with some very low value like minus infinity. And then I am having my base case like dp of 0 0 is 0. Then I am iterating on all the positions from 1 to n, and for j is equal to 0 to 2. So if you don't take it, you will be having this, right? And if you take it, then there are cases like if j is equal to 0, right? And if x of I is equal to 1, so you can't actually take it, so you continue. Otherwise you take the maximum of these two, right? And similarly if j is equal to 1, then again x of I can't be 0, so that's why x of position minus 1, because xi is in 0 based indexing, but I am iterating on positions in 1 base, so in 0 based it will be position minus 1. So if the current xi is 0, you continue, otherwise you take the maximum of this. And at the end I just take the maximum of dp of n0 and dp of n1. Okay, so does anybody have any doubt in this? Okay, so somebody is asking if I'm in level 1, can you? Okay, yeah, you can solve this like it's in dp. You can create a query and I will respond back to you. Okay, so now let us move to the next problem if there are no doubts. So in this problem you are given sequence a consists of n elements like a1 a2 a3 up to n, and initially all the elements are 0, and using an integer k given in the input we define a function f. Okay, we define a function f of a is nothing but the sum of largest k values of a. Why? Because see, let b be the sequence obtained by sorting a in descending order, and then we are taking the first k. So these first k elements will be nothing but the largest k elements of a. Okay, so in summary what we have to do, we have to perform q operation. In the ith operation we replace the element at index xi to yi in array a, and then we find out the sum of largest k elements in this array a and print it. Okay, so the value of n is given around 5 into 10 to the power 5, and xi's and y's are giving their constraints. So let's see what we can do for this. Okay, so basically what we have to do, like initially you were given all zeros like this. Okay, so in each operation you will be replacing some element. Let's say you replace this element with 3. Okay, and after replacing the else replacing one of these elements, you have to find the sum of k largest elements in this array A. Sum of k largest elements. Okay. So how we can do this? We have to always maintain the sum of k largest elements. So that is basically the question. How we can maintain the sum of k largest elements always? Okay. So for maintaining the k largest elements, like it makes sense to use sets or maybe multi-sets since there can be duplicates. So what we will do, like we will be creating two sets, right? Two multi-sets in fact. The first set will be included and the second set will be called as not included. Okay. So the included set will include or like will contain the k largest elements. Okay, this included set will contain the k largest elements, and the not included set will consist of the remaining elements. Remaining elements like that is n minus k other elements. Okay, and we will be having some variable sum. So this sum will be denoting the what is the sum of all the elements in the included set. Okay, so let's see how we can maintain these two sets and this value of the sum dynamically. So let's say we have maintained this included set, so that is there will be like k values like this in this. Okay, so let's say this is greater than equal to greater than equal to greater than. So let's say this is consisting of the k largest elements included set, and then there are some non-included set like this. Okay, so whenever you are given that, let's say you want to make this operation, that is a of xi is equal to yi. Okay, so this operation can be done in two steps. This operation can be done in two steps. The first step is to remove a of xi from the old array. Okay, that is remove a of xi. So whatever is the value of a of xi, we will be removing it from our array. Okay, and the second step will be add the value yi. Okay, that is since a of xi is equal to yi, we add yi to our this previous state. Right. So let's see how we can do this. Right. So for removing ai, how we can do? Let's say the k largest elements are like this: 5, 3, 5, 4, and 3. Let's say these are the, let's say k is equal to 3. Let's say these are the k largest elements. That is included set, and there are some not included set. Let's say not included sets consist of 2 and 1. Okay, now if you have to replace, let's say, some index, that is you have to replace a of xi with, let's say, 6, and previously a of xi was, let's say, 2. Okay, so first of all you have to remove this older value of a of xi. So you will see if a of xi is in your not included set. If it is so, then you will remove it. Otherwise you will check if it is there in your included set. Right, so for example in this case 2 was in the not included set, so you will remove it. Right, after removing it, you have to basically add a of xi. Right, so how you can add a of xi? You see it is 6. You see it is 6. Right, so you will compare that whether it is benefitable to add 6 to here or not. So you compare the smallest value in the included set. It is 3. So if 6 is greater than 3, then what you will do, you will remove this 3, put it into not included, and insert 6 into this. Okay, otherwise you would not include this 6 into included set. Okay, so you will include simply into the not included set if this element was smaller than or equal to 3. Right, you will include
Excuse me,
this.
sir.
Yeah.
So what will happen if 2 is in both included and not included?
Yeah, that's also the case. So let's say if your elements consist of 5, 3, 3, and let's say not included consist of 3, 2, right? And you are saying, let's say a of xi was initially 3 and we have to replace it with 5, right? So you will first of all check whether it is in your not included set or not, right? Don't check directly in the included set. Reason is like, even if you remove 3 from your array, the k largest element will still be these only, right? So first compare whether it is in the not included set or not. So for example, it is there in the not included set. So you will remove it from here. After that, you will try inserting it in this set. Okay.
Sir, I didn't get the point you said about we should check not included first.
Yeah. So let's say, okay, so let's say a of xi was initially 3 and you have to remove 3, right? So it means your elements are like 5, 3, 3, 2, right? So even if you remove some 3 out of this, your k largest elements will still be these only, na? Let's say k was equal to 3. So even if you remove one occurrence of 3, the k largest element will still be these only, right?
Okay, sir.
Okay, so that's why first check whether it is in the not included set or not, because in that way you will be maintaining this set, right? But let's say what happens if a of xi was equal to 5. Let's say a of xi was equal to 5 and we have to replace it with, let's say, 2. Let's say how we can do this. So first of all, check whether 5 is in your not included set. No, 5 is not in the not included set. So you check included, yes, included in there. So you remove it from this. Okay, after removing this, the size of it will become 2. Okay, but you have to make sure that the size is not 2, the size is always 3. So you will kind of rebalance these two. How you will rebalance? You will take out the maximum from this set and put it in this. Okay, so kind of this will become, the maximum from this is 3, so it becomes 3, 3, 3, and this becomes only 2, right? So in this way, you first of all removed the occurrence of a of xi is equal to 5. That is, you removed 5. After that, you have to insert 2, because now the next values of a of xi is 2. So you compare, can you insert 2 in this? No, you cannot insert 2 because 2 is not greater than this smallest value. So that's why 2 will be inserted in this. So that's why it becomes 2 and 2, not included set. Is it clear?
Yes, sir.
Yeah. So basically, we are maintaining two sets. The first set is included set, that is containing the k largest elements. The not included set is containing all the remaining elements, right? And whenever we have to replace a of xi with some yi, first of all, we remove a of xi. First of all, we remove a of xi. And after removing a of xi, we make sure that the included set is of size k. After that, we try to insert the value yi, right? And we try to insert the value of yi into our included set, So we can insert yi into included set if and only if the smallest value in this included set is smaller than this yi, or you can say yi is strictly greater than the smallest value of the included set. Then only it is better to include this. So if you include this, you have to transfer this to first here, and then only you can include it. Otherwise, you can't include yi into included set, so you simply include it into your not included set, right? So let me show my code for the same. Okay, so here I am taking n and q, right? I am declaring included and not included sets. So initially included set will consist of k zeros because all are zeros, and the not included set will contain n minus k zeros. Then I am maintaining a sum and an array a, right? I am taking xi and yi. Then I am decreasing xi to make it zero based. Now I have added a special case like that if k is equal to n, if k is n, then like you just simply have to maintain the sum, right? You don't have to do anything, just maintain the sum. So if k is n, subtract the old value of xi, a of xi, then add the new value, update the a of xi, and print the sum and continue. So this is for special case if k is n. Otherwise, I try to first of all remove the older value of a of xi from the not included set. Then if it is not there in not included, then I erase it from the included set. So since it was included, I subtract it from the sum. Then I update the value of a of xi to yi, right? Then I try to balance the size of the included set. That is, the included set should consist of k elements. So if the size is not k, it will be like k minus 1, definitely. So if it is not k, then I extract what is the largest value in my not included set, insert it into the included set, add it to the value sum, and then erase this from the not included set. Okay, so I am rebalancing, kind of. The included set should always be of size k. After that, I tried to like insert the updated value of a of xi to the included set. So when I can insert only if a of xi is greater than the minimum value of the included set. If it is so, I find the minimum value in the included set, and I erase this from included set, and then I insert it into the not included set, and I also insert the a of xi value to the included set. And since the smallest value was removed, I remove it and add the new value to sum. Otherwise, you have to add it to not included set, so you don't need to do anything, and then you just print the sum. Okay. So this was for D. E. Does anybody have any doubt in the code or like my solution?
Sir, is it possible to solve this question with segmented tree or something?
Segment tree. Maybe you can solve it using segment tree as well, but I think that will be an overkill. Definitely, I think you can solve, but I don't have any idea. Like
Okay.
you will always be maintaining the k largest elements. But I think that will be like too much for this problem. Like you can simply solve this problem by maintaining two sets only. Okay, two
When I
multi.
first saw the problem, it was like query based and it was asking largest k largest element. So the first thought that came into my mind was segment tree, but I
No, but
couldn't
like if you have,
actually
yeah.
implement it.
Mm-hmm. But no, you actually, if you have solved a similar problem, the name was like kth largest or kth smallest element. You remember, like in lead code, you might have solved finding the kth smallest in a running stream of integers. So there we maintained min heap and max heap, or like priority queue kind of thing. Have you solved it?
I
Okay.
think I have, but I couldn't just think of any priority key or something. Means the set approach didn't come to my mind actually.
Yeah. Yeah, lead. So actually, once you solve this problem, you will feel like. So once I saw this problem, like immediately it strike me like I have solved similar problem in lead code where I was maintaining some priority queue, or you cannot say multi-set of k element. So that's why it gave me an intuition that maybe by maintaining multi-sets of included and not included, we can like maintain the states after applying each operation or each query. So that's why did I go with this. For segment tree, I will think about it. Like I currently don't have any approach like how we can solve it using segment tree, but definitely I will give it a thought and will tell you if I got any.
Okay.
Yeah, so this problem where you are given an integer nums and integer k, return the kth element in that. Okay, so this is simple, but there is also a problem where you have to calculate it in a running way. Okay, in a running stream kind of. The length of arrays will not be fixed. It will be coming, elements will be coming one by one. Okay,
We
so
have to
there,
make k size heap, right, for that question when we
yeah,
have to check
you
the
have to,
running heap.
yeah, you have to maintain the k largest elements.
Yes, sir, I solved it in college
Yeah,
actually.
yeah. So it's very similar to this. You will, I got intuition from there only, right? That maintaining k multi-sets of size k, right? Okay. So let us now move to the next problem, which was merge sets. So in this problem, you were given two arrays, let's say A and B, and let's say that A and B have no common elements, that is A intersection B is phi or null. So we are defining a function f of AB as follows, that is, let's say C is equal to C1 C2 C of like the total size of A plus B, be the sequence consisting of A union B elements sorted in ascending order. So basically f of C is nothing but the merge of like sorted merge of A and B, and then take k1 k2 k of mod a such that a is equal to c of k1 c of k2. Then let f of ab is equal to sigma of ki, I varying from 1 to mod of a. Okay, so let me explain you, like it's the statement is a bit complicated, but I will simplify it for you. So basically, let's say there are two arrays, let's say a. So let's say a consists of elements like 5 1 and 4, right? And let's say b consists of three elements, let's say 3 and 6, right? So C is the array, which is basically you combine the arrays A plus B and sort it. So if you combine A and B and sort it, you will get 1, 3, 4, 5, and 6, right? So this is array C, right? Now what you have to do is basically find the consider the array A. Consider the array A. So what are the elements of array A? 5, 1, and 4. So you see 5. Where is 5 occurring in this array C? It's occurring at this position. What is the index? It is 4. So you add 4 plus. Then 1. Where is 1 occurring in this array C? So it's occurring at the first position. So you add 1. Move ahead. Then you have 4. Where is 4 occurring? 4 is occurring at the third index in array C. So you add 3. So in this way, the value of f of A and B will come out to be 7. Okay. So in short, what you have to do, if you have to calculate f of AB, what you do is that you combine A and B and sort it. Okay. So let's call this sorted array C. And after that, for each element in A, you find what is its corresponding position in C. Let's say 5. So 5's corresponding position was position number 4. So you add the value of the positions of each of these elements in array A. And that is what your value of f of AB will be. Okay. So before moving ahead, we need to first of all see a simpler problem. So let's say we are given, let's consider this question only. Let's say this problem where your A was like this. Sorry, A was like this, and B was like this. Okay, sorry. Yeah. So let's say if you want to find the position of 5, how you can find the position of 5 without actually calculating the C, like it without combining A and B and actually sorting it? How you can get to know the position of 5 in the sorted position? So see, what is the position of 5 in the array C? It's 4, right? It's 4. So what it means is that you can see how many elements are smaller than 5. So there are, you see, 3 elements which are smaller than 5. So it means that the position of some element in the array C is nothing but how many elements are smaller than that element plus 1. So for example, if you want to find the position of 5, so how many elements are smaller than 5? They are 3. So 3 plus 1 is 4, right? So the same thing you can see for 4 only. So you see how many elements are smaller than 4? There are 2. So 2 plus 1 is 3. That's why the position of 4 is 3. So what you can do, you can simply see that if this array was 5, 1, and 4, sorry, if this element was 5, 1, and 4, and if you want to find the position of 5, you see how many elements are smaller than 5 in array A, 0, plus how many elements are smaller than 5 in array B. Sorry, in the array A, there are 2 elements smaller than 5. So this will be 2 actually. So how many elements are smaller than 5 in array A? 2, plus how many elements are smaller than 5 in B? That is 1, and then plus 1. So finally you get 4. Okay. So in this way, what you do is that if you are given some array A, okay, and array B, and you have to find, let's say, the position of A of I in the sorted C, that is like A plus B, and this is sorted. If you want to find the position of AI in the array C, what you do is that find how many elements are smaller than AI in array A itself, and how many elements are smaller than AI in the array B. Add them. Let's say this was x1, this was x2. So your position will finally be x1 plus x2 plus 1. Is this clear? Hello. Do you have any doubt in this? Okay. So if no, then we can continue. So this is the way in which you can find out what will be the position of AI in the array C. Okay. You find the smaller elements than AI in array A, plus how many elements are smaller than AI in array B, and add 1 to it. So in this way, you will get the position of this AI. Okay. So what we have to do is that uh, we are basically given m arrays. Sorry, not m arrays. Basically, we are given n arrays. So each array is of length m. Okay, let's say like this. Each array is of length m, and we are given n such arrays. Now, what we have to do for every possible pair of these arrays, we have to calculate their f of that value. So let's say this was array a1, this was array a2, a3, like this. So for every ai aj, we have to calculate the value of it and add it for all possible pairs. Okay, so let us see how we can do this. So let us say that we are considering some array like this. Okay, and let's say these are the arrays which are below it, and we have to consider each pair consisting of this element. Okay, so what we will do, we will just count the contribution of each element. We will count the contribution of each element. So let's say we are considering this element. So we want to count the contribution of this element over each of these. Okay, so let's say if you're considering this one, if you're considering these two pairs. Okay, so let's say there are x1 values which are smaller than this value in this array itself. In this array itself, there are x1 such values which are smaller than this one. Okay, and let's say there are x2 such values which are smaller than this. Let's say the value of this is y. Okay, so let's say there are x2 such values which are smaller than y in this array. Similarly, let's call this to be x3, and let's call it as x4. So if you consider these two pairs, if you consider these two pairs, so the contribution of this y element will be nothing but x1 plus x2 plus 1, right? Similarly, if you consider these two pairs, the contribution of this element will be nothing but x1 plus x3 plus 1, and then when you consider these two pairs, the contribution will be of y will be x1 plus x4 plus 1. So in this way, what you will see is that x1 will be counted 3 times because there were 3 rows below it, right? So your final contribution of x1 of y will be nothing but x1 multiplied by how many elements are below it. So that will be, let's say, n minus I minus 1, considering 0-based indexing, plus these things x2 plus x3 plus x4. So these are nothing but how total how many elements are smaller than y in all of these elements, among all of these elements. So let's say somehow we can calculate it, right? Plus 1 plus 1 plus 1, how many times for each of the rows below it? So that will be nothing but again n minus I minus 1. So in this way you get a formula like this, that is you can take common n minus I minus 1, and it will become like x1 plus 1 into n minus I plus 1 plus this number x2 plus x3 plus x4. This is nothing but how many elements are there which are smaller than y in the rows below it. Okay, so now you can easily calculate these two. The only thing is how you will calculate these, that is how many elements are there which are smaller than y in rows below it. Okay, so let's say you want to calculate how many elements are smaller than y in among all of these elements. So for finding it, you could have used like either segment tree or Fenwick tree, but in order to like optimize or like utilize your time, I would suggest you can use ordered set. So I used ordered set for the same. So ordered set, or this is also called a policy based data structure. So this is very similar to a set, but in addition it contains some additional functions, right? So let me explain you. So in general, set what does what? Set, in set you can insert some element, you can erase some element, find some element, right? So in ordered set, all these operations are there also, right, in ordered set. But there are some additional feature, like you can find how many elements are smaller than some element x in your set, how many elements are smaller than x in the set. So for finding it, you just have to use order of key. So you can call like st dot order of key. Let's say key is 3, so this will return you how many elements are smaller than 3 in your set. Similarly, there is another function called find by order. So find by order does what? Find by order find the kth smallest element. So let's say if you write here 2, this will return you the 2th smallest element in your array, in your set. And this 2 will be basically 0 based indexing. So when you write here 0, you will be getting the smallest element. When you write here 1, you get the second smallest, like this. So these are the two additional features which are offered by the ordered set. So if you maintain these elements, like if you maintain all these lower elements in an ordered set, you can simply call order of y, st dot order of y, and you will be getting how many elements are smaller than y among all these elements, right? So that also works in O of log n, just like sets. So these also work in O of log n, like other operations in set. Okay, so the same thing, you do it for all the elements, and once you have done it for all the elements, you can add all these elements in your ordered set and move to the rows above it. Okay, so this is what the final solution. So finally the solutions look like this. That is, you calculate these values. So for each of these elements, so for each of these, let's say yi, you calculate its contribution. So the contribution will be like this: x1 plus 1 multiplied by this plus this. This can be found in O of log n, or not exactly log n. This will be actually log of n into m, the total elements, and this can be found easily. This you can calculate easily beforehand only. So what you can do, you can sort each of the rows independently. Okay, you can sort each of the rows independently. So if you are at the ith element of this array, so you know there are I elements shorter than this or smaller than this in this array itself. Since the order of the elements in a row does not matter, so you will sort all the elements in each row, right? So that you can easily get this x1 value, that is how many values are lesser than x, how many values are lesser than, let's say, y in this array only. Okay, so let me go to my solution to show you. Okay, so for including or like for using ordered set or policy based data structure, you have to include two additional libraries as well. So these are the two additional libraries that you have to use, and also you have to use this namespace underscore underscore gnu pbds, right? And you have to define your ordered set like this. Okay, so you have to use this tree template, right? And if you are making an ordered set of long, so you place here ll. If you have to make it of int, you place int. If of pair of int, you can write here pair of int, like that. Okay, so let's move ahead. So we have taken here n and m, right? Now I have maintained a of nm. This is a 2D array for storing all the aij values. So I took all the aij values. Okay, then what I do is that I sorted each row of my array. Okay, or like each row. So how we sorted each row? Basically, I maintained all the elements of the current row in a vector v, sorted that vector, and just replace a of ij with v of j. So after doing this, each row will be sorted now. Now I declare an ordered set, right? I start from the last row going to the above rows. So let's say I am at the ith row. So for each element in the ith row, I find how many elements are smaller than this by using order of key function. And then I just add n minus I minus 1 into j plus 1. So this is actually this which I was telling you, this thing. So this is the factor that I am adding. And this was the another factor which I was adding. Okay, so this factor is returned by order of key using ordered set, and this is what we already have in O of 1. Okay, so add these two, and at the end uh, update your ordered set by adding all the elements of the current row, and at the end just print your answer, right? So this was the solution for problem F. Do you have any queries? Okay, so if you don't have any queries, we can stop here.